Let's continue with loci of a complex number. Alright, so let's go to more examples of the last loci. Okay, we have got argument of sec equals to pi over 4. If I were to draw, again it should be a half a line from the origin because I didn't give you any a, so a should be just 0, 0. I'm going to draw half a line like that and I will just leave it like that. Okay, what then for argument of sec less than and equivalent to pi over 4? Before you could do any shading, you will need to first draw a line. If this is the line that you draw, where then do I shade? If it is a less than and equivalent to, I will have to shade it here. Okay, what about for the last one, argument of sec more than pi over 4? Again, you have to first draw half a line, which is with an angle of pi over 4, and then after that, shade it on this side. But what not to forget to do, since there is no equal with this more than, you have to leave your half a line as dotted. Why? Because angle wouldn't be pi over 4, but more than pi over 4, right? So what happened if it is a negative? Okay, argument of sec equivalent to negative pi over 4 would give you something like this. Okay, negative angle means it should come in clockwise direction. What about for argument of sec less than and equivalent to negative pi over 4? I'm going to still draw half a line like that. And this half a line should be a solid line because it could also be an argument of sec equivalent to pi over 4. Where should I shade? If it is a less than, I should be shading on this side. Okay, it is always the opposite, remember? Alright, it is always the opposite. If it is a less than here, a more than there. For a negative, it should be a more than here, a less than there. Alright, what about for argument of sec more than negative pi over 4? I'm going to still draw a half a line and leave this half a line as a dotted. Where do I shade? Do I shade it on the right or do I shade it on the left? It should be on the right. You are correct. Okay, am I clear on this part? So what happened then if it is argument of I sec equals to pi over 4? We have been dealing with argument of sec. Yeah, because we know the Argand diagram of sec. And Argand diagram of sec is simply this. Real part is here, imaginary part is there. Correct or not? You have got 1 here, you have got negative 1 here, you have got I here, you have got negative I there. But what happened if I were to deal with the Argand diagram of I sec? You will now get a diagram like this. Okay, this is for sec. I wanted now I sec. So what then should I do? I'm going to multiply 1 by I. I'm going to multiply I by I, which will give me negative 1. I'm going to multiply negative 1 by I, which will give me negative I. And one last one, I'm going to multiply negative I by I, which will give me 1. So when you look at it, I have actually turned the whole graph, am I correct? So how have I turned it? I have now my real part to be here, if you could tilt your head a little bit, and I will now have my imaginary part of sec to be there. Okay, I used to have my first quadrant to be here for Argand diagram of sec, my second quadrant to be there, my third quadrant to be here, and my fourth quadrant to be there. With I sec, I should have my first quadrant to be here, my second quadrant to be there, my third quadrant to be here, and my fourth quadrant to be there. So where then do you think I should be drawing my pi over 4? This is my first quadrant, hence I should be drawing a line like this. So what happened if I were to ask you for a less than and an equivalent to pi over 4? Since this is now my new quadrant, I should be shading over here. Okay, right? But is this the only way to do it? Do I have to all the time draw a brand new Argand diagram? There is no need to do that. You got to simply do something like this. Argument of I sec, okay, we are going to still work on argument of I sec equals to pi over 4. Since we are comfortable with the Argand diagram of sec, we are going to try to find what is the equivalent argument of sec to the argument of I sec equals to pi over 4. So argument of I sec equals to pi over 4 is simply argument of I plus by the argument of sec equals to pi over 4. So how did I separate argument of I sec into argument of I plus argument of sec? I've simply used what we have learned earlier with polar form, where we say when you have two complex numbers to multiply, you are supposed to add the arguments, remember? So I is one complex number, sec is another complex number, I sec is simply the multiplication of I with sec. So what are you supposed to do when it is the argument of I sec that I wanted? It is simply the argument of I sum with the argument of sec. So what is the argument of I? Note that cis pi over 2 is equals to I. So what is the argument of I? It is just pi over 2. I'm going to put here pi over 2 plus by argument of sec equals to pi over 4, which will give me argument of sec equals to pi over 4 minus pi over 2, which is argument of sec equals to negative pi over 4. So how should I draw this one? Argument of I sec equals to pi over 4. I got to simply draw argument of sec equals to negative pi over 4 because they are the same. So how am I supposed to draw it? Argument of sec equals to negative pi over 4 is simply there. Okay, makes sense to you? Right, so we are done with the general loci of complex numbers. Let's move on to non-general loci. Non-general loci in the sense, if you don't see that three forms I have taught you earlier, the modulus of sec equals to k, the argument of sec equals to k, or the modulus of sec minus a equals to the modulus of sec minus b, that is when you have to treat it as non-general loci. So what is non-general loci? You got to simply change whatever equation or inequalities given to you into a known Cartesian form. Note that real part of sec is simply x. We are always taking sec to be x plus yi. And note that imaginary part of sec is y. So what is x plus y more than and equivalent to 0? It is simply a graph like this. Okay, so where do I shade? It is y more than and equivalent to negative x. So I drew y equals to negative x, and more than and equivalent to means I will have to shade it up here. Note that with all loci of complex numbers, we usually get you to sketch it. If not, we'll probably sketch it and ask you to come up with the equation or inequality accordingly. Right? And what then for this one? Note that y is imaginary part of sec. It is y more than negative 2, less than and equivalent to 3. So what then should I draw? Y equals to negative 2 is a horizontal line. I leave it as a dotted line because there is no equal with negative 2. What about y equals to 3? It is a horizontal line. What does it mean by y is in between negative 2 and 3? I got to just shade it in between. So for whatever form that you don't see as general, always convert it into Cartesian form. That is when you can easily draw. Alright? And also note that loci of complex numbers can be given as combination of two loci. Hence you got to just work accordingly. Alright? So what does it mean by combination of two loci? Okay, let me just give you a brief example. Let's just say I wanted the argument of sec more than negative pi over 4 and the modulus of sec less than and equivalent to 1. So how should I work on this one? I have drawn the argument of sec more than negative pi over 4, which is the shaded part in red. What about modulus of sec less than and equivalent to 1? It is simply a circle with center at origin with a radius of 1. Am I correct? Yeah, so what does it mean by end? Okay, let me just shade it in blue. Okay, so what does it mean by end? End means intersect, right? So which part is it that I wanted out of these two loci? I wanted only this. The part that I've just darkened. Make sense to you? Pretty easy to do loci, isn't it?